Hello, everybody. Welcome to the screencast. Jovis here, and this is test-driven development on Android. In this episode, we are going to wrap up the search functionality using the outside-in TDD approach. I will do a little retrospective, and then from the next video, we're going to work on the same exercise using the inside-out approach. So let's get into it. First, I need to do a little setup here. Here is the acceptance test, and in a previous episode where we ended up is we came up with an in-memory search service, and we leveraged that fake in order to create our contract tests. And now let's go ahead and see how we can create a real implementation, let's say a remote search service. So I'm going to start off by the test, and I'll say this is a remote search service should. And that's gonna be my test. I'm gonna derive here from the search service contract. Of course, I'll have to implement these three functions. Let's do a little formatting here. And basically what I have to do here is I have to provide a search service, and it has to comply on the contract. So let's say I'm gonna return a remote search service. And of course, I don't have this type at this moment. Let's go ahead and create it. And I'll extract it into a separate file in the search package in the source. And I'll move it on the right side so we can see both of them at the same time. And this should override the search method. Right. So this is our remote search service, and how we would typically do a call to remote, let's say, to an API. On Android, we would use some library like Retrofit, let's say. And how it works is basically we define an interface where we are going to describe the calls like get, post, put, whatever. And then Retrofit creates an implementation out of it. So we don't really work with a low level, but basically I can actually create a real integration test. I can do the actual real calls here, but that's definitely not what I want to do here in the test. I just want to, I'm just going to use, again, a fake for the, that's going to sort of, mimic the behavior of my possible backend that I'm going to have. So let's say the typical way how we're going to do that is like I would return here an API.search, let's say the query. So I'm just going to call an API. Okay, this is going to make me a problem, I guess. And then this API, I'm going to introduce it as a constructor parameter here. That's going to be a search API, let's say. So let's go ahead and refactor. And I think this should be a private thing. Now I don't have this API, and I'll create it. So as I said, we need an interface, and I'll extract it into a separate file, but I'll put it into a package of its own. And how we would normally have this done is like we're gonna have, let's say, a get. It would do a lookup. I don't know, search. Then we're gonna have a query, and then here we're gonna have a keyword, and it would return a list of string. Let's do a little formatting as well here. So that's how we specify an API, and then if this is retrofit, for example, this is how typically we would do the things on Android. That's my remote search service now. And of course, this does not compile. So now in my test, instead of actually having the real real implementation of the API, I'm just gonna go ahead and create fakes for this test here. For example, offline API. And that's gonna be a class that I'll keep here in the test because it's relevant only in this test here. And the behavior of that one would be, it would just throw an IO exception. IO exception. So that's how I mimic basically being an offline. So I'm trying to reach out an API, it throws an IO exception. So basically, there is some bad internet connection or something like that. So I'm unable to reach out to the API entirely. And here we go. It says there should be an out of internet exception, but it's IO exception. So let's make this work. And that's gonna be, let's say, a try. And then catch an IO, sorry, catch IO exception. And then this is gonna throw a out of internet exception. So essentially, I'm just mapping the IO into an out of internet exception. We are gonna talk a little bit about these decisions that I made using the exceptions a little bit later. Let's first make this work. Anyway, now I have my test passing, as we can see, and then I have 3 tests to go. Okay, I'm thinking I'm not gonna make intermediate commits. Let's work the whole thing out first, just to save some time. So now I'll here return again a remote search service, and now I'm gonna use a stub. Let's say stub search API, and I'll pass there all items. Dim. So this should be class inside here. I have a all items, and it's a search API. So let's do a little formatting here. Of course, I need to implement the search. And now, essentially, I'll move this up because I want to keep the functions, you know, on the top, and then the classes here on the bottom. Essentially here I have to mimic the behavior of my API. So if I had a real API, I would have a specification, for example, what's going to be returned, like let's say 200, and then how will be the structure of the response. Or if I have a bad search, for example, 403, those things. But because I don't have, I just have to, you know, use my imagination here, but it's not a rocket science. Most of the REST APIs that we would normally use are behaving the same. So I assume that here the search API, when I call search, it would just return items that are containing the keyword. So I would say return all items, comma, filter it contains the keyword, and it won't put attention. Like I have to, yeah. This is a big problem. They updated the Zoom. I updated my Zoom, which I'm using for recording, because I'm really bad at using software for recording, and in order to show, yeah, for some reason they are just popping up the controls back there when I press escape. So now I have, as we can see, 2 tests passing, 2 to go. And now for the search service without, I'm going to use the same stuff. Remote search service, stop search API. And then here I'm going to use the all items, but in reverse. Like I'm going to flip the values. So let's say reversed items. And it's going to be all items, just map it reversed. Something like this, run. Now I expect 3 tests to pass. Right. And then I have to work on the bad search exception. So I just assume that, let's say if I pass an empty query to the backend, it's going to return 403. So let's create that behavior on my sort of supposed to have backend. So I would say verify not verify, but validate my keyword. And then the validate will be a function here. And I would say if the keyword is blank, then throw HTTP exception. And this should be a response. Why the first touch to the escape button is showing this response? It's going to be a local response. Response.error. Let's say 403, and then here I'll have body, and then the body is gonna be response body create. The media type can be null, and this will be, say, empty keyword, something like this. So now if I run, my search service will return the HTTP instead of bad search. Exactly. So it returns HTTP exceptions. It throws. So I'll do here catch HTTP exception. And then here I can, go ahead and check if the HTTP exception code is 403, then throw the bad search exception, otherwise throw the actual exception and so on. But for this, I mean, you already got the point. So for this exercise, I'm just gonna throw a bad search exception. Now if I run, the test should work. Cool. Now all my tests are passing. And the cool thing is that now if I open my contract, and if I try to run, it asks me which one to run. So I can run all of them. And then I can see in the result, you see here that both implementations, the in-memory and the remote, are compliant with the contract. So that's really the cool thing here. So I think now I have the implementation of my remote search service. And now if I want, I can use that one, for example, for the real application, and use the in-memory search service for my tests. And as you can imagine, now writing UI tests, for example, it's going to be super easy because the tests going to run fast. They won't be as flaky as they would if I'm using a real call, for example. Because if I do a real call to database or to a network, then there is a latency, there is a waiting, and so on. But if I leverage the use of the in-memory search service, they're gonna run fast, which is cool. And I have the contract to make sure that the in-memory and the real implementation work as expected. The behavior is sort of in the same line. So first, let's check this in. Introduced a remote search service. Cool. And now another thing that I wanted to show is, yeah, first, well, there is no changes in terms of the acceptance test. It's gonna work. In my searcher here, if I, use the setup as it is, the call to the search is gonna happen in the main thread, because probably the search will be called in the main thread, and we don't want that, because if I'm using the real the remote search API, then I don't want the call to be happening in the main thread, because it will block the UI and so on, or I might even end up with an exception that I do an operation, long running operation in the main thread. So I want to offload that. So there are two things that I can do here. I can either create a scope that's going to be bound to the searcher. I'm talking in terms of coroutines. I can create custom scope, or I can actually derive here from a view model, which is sort of typical nowadays on Android. I know that some people absolutely hate the view model and they are preaching not to use that. But for this exercise, everything's going to be fine if we just use the view model. And then here, what we can do is we can use the view model scope to launch a coroutine, and then do the actual call inside the coroutine. But if I launch here, I'm still in the main thread, so I have to do the actual search. Let's say this is gonna be called results. I want to make this one, I want to offload into a background thread. So I'll do with context dispatchers.io, for example, and then do the call. And then in this line, I'm already back in the main thread, so everything's gonna be fine. Now I wanna run my acceptance test again to make sure that everything is still in line. And now it is running and it's green. So just to see how everything's gonna work, I prepared a little demo. So I created an activity where I prepared a list of sort of items that I might have, and I'm creating an instance of the in-memory search service, and then do the whole wiring here. Normally on Android, we would have a dependency injection, and then just inject the searcher here, but this is basically what happens. How the object graph would look like. This is the wiring here is the essential part. And then I have a very simple layout that has a, if you watch the sequence diagram, like the actual beginning of this entire exercise, excuse me, then then you probably know how the screen would look like. There is just a search box, and then, in fact, let's run it. No, I'm running the test now again. And here I have the emulator. What I wanted to say, yeah, so this is the just a search view, and I have a text view here that's gonna display the results of the search. So if I type, let's say, a short query, it tells here that the query is not valid. But if I type, let's say, some longer query and search, it tells me that there are no matches. And what else I can do is search for an item, and then I can see here a bunch of items as a result. So the cool thing here is that essentially my UI is pretty simple. It just observes the state of the search, and based on the actual state, it would alter the UI to do the thing, either like show loading or display the actual results. I use the same text view here, as we can see. I just created separate functions, but the same text view is used to display the results. And what I have here is I'm just using a text query listener to submit the query to the searcher. So essentially, I'm just sending events to the searcher, and I'm observing from the searcher the states that I want to render. As simple as that. So that's gonna be the demo. So as we saw here, now we have the entire exercise. I'm just gonna check this in as well. Performing search in the background thread. So let's take a look now at the whole picture, from top. So we have our acceptance test, and we did not only use the acceptance test to guide us through the whole, architecture to tell us when we are done. The important part of the acceptance test is that if we happen to refactor the things later, let's say now all the except the acceptance test, the other tests, let's say for the searcher should. So this test here, it tests the class in isolation. So I'm just using mocks here to construct this searcher class. The validator and the repository, they are mocks. But the point is that why some people are saying that, when you're using mocks, you are making brittle tests. It couples the test with the implementation details, and that's correct. That's not wrong, anything there. But like in this case, in a searcher, the search functionality only has here a behavior, and I would say a pretty important behavior. It does not deal with any states here, but this behavior is super important for the whole thing. And if I happen to change this behavior, I want an indication that something goes wrong. So I want a failing test. So in that sense, having these tests here are completely fine. But the problem is that if I happen to change, let's say, the actual implementation of the validator, then this class is using a mock that is stubbing the return to always return, for example, a true or false. So I may not catch a possible regression that I may introduce by changing the validator, intentionally or not intentionally. And that's why the acceptance test is really important at this point. So the acceptance test is always having real implementation. It uses the real implementation of the classes. And if I introduce possible regression, I want to be able to catch that regression. So I wrote an article that works into all these things in details. You can find the link below in the video descriptions. Go ahead and read it. Most probably everything's gonna get more clear. So as I said, the pitfall of the outside in TDD, like one of the bad parts is that we do use, by using the mocks, we have to, we have to find balance, what to test, in what way to test, and so on. Then another thing I want to point out is that repository should. Here, I've decided, when I was working on this part, I've decided to use exceptions to model the error states for my, to transfer to translate the error states that might happen in the outside world into my domain. So I could have used, for example, in the search state class, I could have introduced objects for those. I could have modeled them that way, or I could have come up with entirely different type. So the exception itself is sort of a domain type that I want to. I just happened to create exceptions because I wanted to make it explicit that it's exceptional situation that is going on. But essentially, the beauty of working in pairs or mobbing, when we are doing such things, is to get these decisions together. Because I was working alone here, I decided to use exception because I like to be explicit about the exceptional situation. It would have been completely fine if I used any other type. And then the last thing I want to point out is that some tests, the names of some tests are, uh, you know, so here I think that the names are fine, but I noticed at some tests that I'm using too much, the test names are too much bound with what's really happening, they're not abstract enough in a sense. Like if I happen to do some changes, let's say here, for example, the searches the repository for a valid query. It would have been better if I get rid of the actual repository in the name of the test. So like come up with a name that would not involve the repository itself. So it would have been better because the test name would be more abstract and it wouldn't be really bound with what's really happening here. In a sense. So it just focuses on the actual behavior that is being exercised. Um, but yeah, I think those are sort of little things. And as I said, if we were working in pair with somebody else or mobbing, we would come up with those. Those are really implementation details. And then we would come up with, let's say, together with the names, and then everything's going to be better. But in general, I think this would wrap up the whole outside in approach. This is how we would use the outside in to, to work on features on Android, or like this can be applied on backend or whatever. Really, it doesn't matter. That's the essentials of the outside in are shown in this screencast. And then I think from the next episode, we are starting with the inside out approach, which is the Chicago school. And then I think it will be interesting to see and to compare both styles, how they how they differ, what's better, what's worse in the first one or in the second one. But I want to point out once again that using both styles in the same time is completely fine. We are not really using either this or that. We can mix and match both of them, as we saw throughout this exercise. For example, when I was working on the validator, I was actually using the Chicago school. So also for the boundaries, for the in-memory search service, the fake, when I was doing the triangulation and stuff. But I was going with a bit bigger steps. I think now with redoing the whole exercise from scratch, we are gonna see more little baby steps, and then work towards the final solution to see how that's gonna work. I think that's gonna be it for this episode. I'm really thankful for the time and for watching it. I'm looking forward to see you in the next one. So yeah, take care. Bye bye.